What if a piece of another solar system suddenly passed through ours? A traveler carrying secrets billions of years old, untouched, unexplored, and moving so fast we may never see it again. That's not science fiction. That's 3I Atlas, the interstellar comet discovered in 2025. Where did it come from? What is it made of? And could it change the way we understand the universe? Welcome back. Today we're exploring one of the most exciting discoveries in modern astronomy, 3I Atlas, the third confirmed interstellar object ever seen by humanity. Together, we'll uncover how it was found, why it matters, what mysteries it holds, and what it could mean for the future of space exploration. The story begins in July 2025. The Atlas survey system, designed to scan the skies for hazardous asteroids, picked up something unusual. At first, it looked like a comet, but the calculations showed a path unlike anything bound to our sun. Its orbit was hyperbolic, meaning it wasn't from here. It wasn't coming back. This was no ordinary comet. It was a visitor from another star. Scientists quickly designated it 3I, a TLA, as the 3I, marking it as the third known interstellar object after Oumuamua in 2017 and Borisov in 2019. Think about that. Out of billions of comets and asteroids in our solar system, only 3 confirmed outsiders have ever been seen. The rarity alone makes Atlas extraordinary. Let's talk about its path. At its closest approach to the Sun, October 30th, 2025, Atlas will swing into about 1.4 astronomical units. That's just beyond Earth's orbit. But don't worry, its closest approach to Earth is about 1.80 or more than 270 million kilometers away. That's nearly twice the distance from Earth to the Sun, so there's no danger. But because it's traveling tens of kilometers every second, it will be gone before we know it. What do we know about what it is? Hubble observations suggest its nucleus could be as large as 5.5 kilometers wide. That's about 3.5 miles. It might be smaller, but it's still big compared to most comets. And like a typical comet, Atlas has developed a coma, a cloud of gas and dust and a faint tail streaming behind it. That tells us it's icy, and it's warming up as it passes through sunlight. In some ways, it looks familiar. In other ways, it's a total mystery. Where did Atlas come from? The best guess is that it was ejected during the early days of planet formation in another solar system. Imagine giant planets tugging on leftover debris, flinging some pieces out into interstellar space. For billions of years, Atlas has drifted alone in the dark between stars until it finally wandered into our neighborhood. That's why scientists are so fascinated. It's a free sample from another star system, a message in a bottle that crossed light years to reach us. Studying Atlas isn't easy. Even at closest approach, it's far away, faint, and moving too quickly for any spacecraft we currently have to intercept. Ideas have been floated about redirecting probes like New Horizons, but the timing doesn't work. So for now, we rely on telescopes, Hubble, the James Webb Space Telescope, and ground-based observatories to capture every photon of data they can. What can we learn? By analyzing its light, scientists can identify gases and dust in its coma. That chemistry can tell us whether the building blocks of life, like organic molecules, are present. It can also help us compare Atlas with comets from our own solar system. If it looks the same, maybe planetary systems across the galaxy form in similar ways. If it's different, that could mean the recipe for planets varies from star to star. This is why interstellar objects are so valuable. With Oumuamua, we saw something strange, cigar-shaped or pancake-shaped with no visible tail. With Borisov, we saw a comet that looked almost ordinary, except it was born around another star. Now, with Atlas, we see something bigger, brighter, and clearer than before. Each one is a puzzle piece in the bigger picture of how common planetary systems really are. Some theories even suggest that objects like Atlas could help spread life between stars. The idea of panspermia, life, or at least its ingredients, hitchhiking across the galaxy on comets, has been debated for decades. If Atlas carries organic material, It could mean that the seeds of life travel far more easily than we thought. It's not proof, but it's fuel for some of the most profound questions humanity can ask. Of course, there are bold speculations. When Oumuamua was discovered, some researchers wondered if it could be an alien probe. The same whispers have surfaced about Atlas, but the evidence strongly points to a natural origin, a comet, not a spacecraft. Still, the fact that we even ask these questions shows how much these visitors fire our imagination. So what's next? Future observatories like the Vera Rubin Observatory will scan the skies with incredible sensitivity, likely spotting many more interstellar objects. And there are proposals for ready-to-launch intercept missions, spacecraft waiting on standby, prepared to chase the next visitor the moment it's spotted. If those missions happen, we could one day study an interstellar object up close, maybe even sample its surface. But for now, Atlas will remain out of reach. We'll watch it as it swings past the sun, record as much data as possible, and then say goodbye as it drifts back into the galactic night. So here's the takeaway. Three-Eye Atlas is not just another comet. It's a messenger from another star, a fragment of a world we'll never see, passing through our skies for the briefest of moments. It reminds us that our solar system is not isolated. It's part of a vast dynamic galaxy where material, and maybe life itself, can travel across unimaginable distances. If that thought excites you as much as it excites me, make sure to hit the like button and subscribe for more explorations of the universe's greatest mysteries. And let me leave you with this question. If you could design a mission to chase down an interstellar visitor like Atlas, what would you want to discover first? Signs of life, exotic chemistry, or simply the unknown? Share your thoughts in the comments, because the more we imagine, the closer we come to making it reality.